we propose a generative model to synthesize variations of human motion. In this video, we will give a brief introduction to the proposed method, and show some synthesized motions. The skeleton representation in our system is divided into 5 partitions, to reduce the complexity and to obtain the dependency between joints. The relationships between joints in the same partition are formalized as the conditional dependency between one joint and its parent joints. The conditional dependency is modeled with semi-parametric latent factor model. To synthesize one specific motion, a small set of this type motions are required to train the parameters of the semi-parametric latent factor model. New variants can then be synthesized by sampling from the learned semi-parametric latent factor model. Here, we show some synthesized variants created by our method. We can observe that the variants preserve the major features of the original motion, and demonstrate variations in spatio-temporal domain. For the jumping jack motion, the heights of swing arms and jumping legs also varied among different variants. The synthesized variants of walking motion had different degrees of arm swing as well as the stride length. For the single-leg hopping motion, the maximum height reached by the jumping motion varied across the variants. For the Tai Chi motion, the range of movement varied at different phases. To evaluate the naturalness of the motion synthesized by our method, we compared the synthesized motions with motion capture data, by conducting a user study evaluation. We create a set of motions consisting of motion capture data and our synthesized motion data. Participants were asked to give a score for each motion based on its naturalness, without knowing whether the displayed motion is captured or synthesized. Two-way analysis of variance result is summarized here. It indicates that there is no significant difference between the motions synthesized by our method and the captured motions in terms of naturalness. We compared our method with related methods that can be used to generate motion variations. Here are the variants created using Perlin noise. Comparing to our method, the motions contain more jittery movements. We also compared our method with a dynamic Bayesian network-based approach proposed by Zhou et al. In 2010. To better observe the variations, the synthesized variants are overlapped in the same location. The motions synthesized by our approach are put at the bottom side. Upper side is the motion synthesized by Zhou et al. We can observe that the motions produced by our method display more variations,